All right, this is 2-5 notes. It's going over postulates and paragraph proofs. So here we have a postulate. What it is a statement that is accepted as true without proof. Basic ideas about points, lines, and planes can be stated as postulates. So pretty much there are 7 of these postulates, or you can call them axioms, that are just statements where you do not have to prove them. So here's the first one we're going to go over. Through any 2 points, there is exactly 1 line. So what I'm going to do, I'm going to make this a little bit bigger here. So I have 2 points. So here's A, here's B. Through any 2 points, you can draw exactly 1 line. And boom, there you go. There's 2.1. Okay, 2.2 says through any 3 non-collinear points, there is exactly 1 plane. So what I'm going to do here, draw my 3 little points. Okay, so I can call it point C, D, and E, and we have exactly 1 plane. Alright, the next one, 2.3, says a line contains at least 2 points. So whenever you look at a line, okay, there's actually an infinite amount of points on there, but you will always have 2 points because you have to have at least 2 points to make a line. Same for 2.4. It says at least a plane contains at least 3 points. So if you have your little plane here, okay, you're going to have at least 3 points that are non-collinear inside your plane because 3 non-collinear points make up your plane. Alright, here we go. If 2 points lie in a plane, then the entire line containing those points lies in the plane. So what that's going to look like is I'm going to draw my plane. Okay, so if I have 2 points, so there's K, there's L, then the line containing those 2 points lies in this plane. And again, this is a video, so remember, you can pause this, rewind it, watch this as many times as you need to. All right, next one, so 2.6 says if 2 lines intersect, then their intersection is exactly 1 point. So here's a line. Here's another line. Those 2 lines intersect at 1 point. Okay, in 2.7, if 2 planes intersect, then their intersection is a line. Now, y'all know this is a very, very hard picture to draw. So what I want you to do, so we're not wasting so much time on drawing this picture that you'll never have to draw again, okay, is I want you to write down to remember the 2 papers that were intersecting. At the beginning of the year, I took 2 pieces of papers and showed you how they intersect, and they made that 1 line. Okay, so it says here you can use postulates to explain your reasoning when analyzing statements. So here's examples. So we're going to do determine whether the following statement is always true, sometimes true, or never true. If 2 coplanar lines intersect, then the point of intersection lies in the same plane as the 2 lines. So first I'm going to draw a picture. Okay, it tells me here that if 2 coplanar lines intersect, so that means these are 2 lines that are in the plane. So let me draw a plane real quick. All right, if 2 coplanar lines intersect, so these are lines that are in the plane. If they intersect, then it says, then the point of intersection lies in the same plane as the 2. All right, this will always be true. And the postulate that we're going to use is postulate 2.5. So if you go back up and look at 2.5, it says, if 2 points lie in a plane, then the entire line containing those points lie in the plane. So when you have 2 lines that intersect, the point of intersection will always be in the plane. All right, and then the second one, 4 points are non-collinear. If you can do a counterexample, then sometimes this can be true, sometimes not. So this can be true. You can have 4 points that are on a line, and so that can prove that it's not collinear. Or you can have 4 points that look like this. So here's my 2 point, and you have 1, 2, 3, 4. There's 4 points that are non-collinear, but I could also have something that looks like this. 1, 2, 3, 4. There's 4 points that are collinear. So for this one, this is sometimes true. And the postulate that you would refer to for this one would be 2.3. Alright, so we have one paragraph proof to do as an example, and then we are done with these notes. So here we go. Proof. A logical argument in which each statement you make is supported by a statement that is accepted to be true. Okay, so I'm going to highlight this right here because it's very, very important. Okay, each statement you make is supported by a statement that is accepted to be true. Once a statement has been proven to be true, it is called a theorem and can be used as a reason to justify statements in other proofs. So there are 3 steps in creating a proof. Okay, the first one here is you're going to use the given info. You use this given info, okay, to create a hypothesis. Once you do that, your second step is to use statements and justifications. Then the last thing is you prove by coming up with your conclusion. So you are proving whatever it is you had at the beginning, and that is your conclusion. Okay, so paragraph proof. This is an informal proof. It is a written paragraph that explains why a conjecture for a given situation is true. So we're only going to do one example here. It says, given that M is the midpoint of XY. So I'm going to just stop right there and I'm going to highlight that. M is the midpoint of XY. Okay, so there's my hypothesis. Write a paragraph proof to show, so that showing part, my conclusion is that XM is congruent to MY. So first I'm going to write down my given, so my hypothesis is that M is the midpoint of XY. And I'm going to prove that XM is congruent to MY. Alright, so here comes the writing. So here's our proof. If M is the midpoint of XY, then the measure of XM is equal to the measure of MY. Because of the definition of midpoint. If the measure of XM equals the measure of MY, then XM is congruent to MY by the definition of congruence. And that is it. That's your paragraph proof.